Hi, my name is Tim Deneen with Food Extrusion Dies. Welcome to Die Talks, a knowledge-based video series discussing food extrusion die solutions for the cereal, snack, ingredients, and pet food industry. Today's focus on Die Talks is going to be dead space, the invisible production killer. And it is exactly that. And people don't even realize or see it sometimes, but two of the things we're going to be talking about that you can find out if you have dead space in there, if you're running white product or really light colors, after so many hours of production running or days even weeks, you'll start getting dark streaks through it. Well, what that comes from is the dead space inside the die where material is not flowing and it is overcooking until it gets brown and dark. Then little bits of it start coming off into there. The other part of that can happen is you'll get a chunk come out and it'll clog a die. And all of a sudden your production will slow down. You don't even know why. You may not even know it did. And then it maybe blows itself through after a few hours or it doesn't. So that's why we call that the invisible production killer, because dead space is exactly that. This is what we're going to be discussing in this video. So dead space, let's get into it a little bit. And we're going to have a few different 3D printed dies. This is basically a simulation of a insert. Actually, I'll show you this real quick. It's a simulation of a loop die. Ta-da! But we have a couple other things where we're going to actually show you whole dies and everything. But the first one, we're just going to generally talk about dead space. Then we'll talk about how to improve it in other dies and situations. So dead space is this side over here. So you see how this side, your flow is coming down through this way and it's going there and it tapers off and comes in. So this side does not have that. So what ends up happening is your flow's coming in and it's slowly building up here. And you get a little bit, and pretty much it gets to be exactly what this side is, but instead of it being steel right there, it's actually material that has filled all that up. So now your flow is just coming around there. This, just like this side, is just like that side. So when that comes through there, now this overcooks and gets brown, and then little chunklets of that, that's a great word, isn't it? Comes out, breaks, and it goes through your die. You know, you may be running a rice die, you may be running some exotic shape, maybe a loose die. Depending on how big that particle comes in there, it may clog that up. You may start, if you were running a loop die, you might start getting C's for a while, or something fragments that fall through the screens, or you may just get a dark streak where that part isn't already crusted, but it's kind of oozy and it's kind of dripping in the brown. And you're like, why do I have brown streaks on this? Why didn't I before? Because of dead space. That's exactly what it is. So dead space solutions, that's what we're going to talk about right now. So mainly the dies that have been made in the past, 50 years in history. Looking at it, something similar to a die like this, not really an insert that we were talking about before. This is what they look like. Comes down, you have something channeling, you may have a cone right here, funneling things over, and then it looks like this on the inside. So what ends up happening, again, is you get dead space building up all around this area, and you get a little bit of dead space here. Sometimes the little or smaller parts of dead space are the worst ones. If you have a big dead space and you're running dark product, you may not notice it as much. But if you're running dark product, you have little tiny holes, and then this little sliver around here builds up, that breaks off there easier. So sometimes the smallest part of dead space is causing you problems and the bigger part isn't. So what we've done is we've broken this up into three different sections. We have level 1 die flow, which is this. And some people want that still. This is obviously cheaper to manufacture than something that is what we call a level 3, which in this, and again, every die has its own solutions. So every die has engineering that's built into it when you're going from a level 1 to a level 2 or a level 3. So in the level 3, we actually have, you can see this, and my markering isn't that great on it, but we need to just show up on camera. So you have a taller cone coming through there. You have a tapered side. Everything funnels right to the center of it. And then there's a chamfer that builds up around there. So basically everything is funneling into your holes. There's no dead space being left. Everything cleans out. At the very end of this video, we're going to talk about how to test and look at your solution afterwards when you take your die out. But that's part of the end of the movie video. So again, we have level 1. Level 2 is basically where we, throw a chamfer around here. We kind of radius this right in the corner. We may take that little edge out right there. And we may chamfer these holes. May even put a bigger flow in the holes too. A lot of times customers don't build in a bigger pilot hole coming in there to feed it. Doesn't really show it on this one, but there's a bigger pilot hole in this one. A lot of times they don't do that. That helps when you get clogging. When you have more of a feed on the back of that versus straight down with the same diameter hole all the way down, that creates problems in itself. The more area you can pull from it, the more pressure it gets to push it through. So level 1 is this die right here. Level 2 is this with chamfers built into it and funneling in the holes to help draw things. And when you're drawing on a bit bigger area, you're also leaving less dead space in there. That's level 2. Level 3 is a die that has funneling everywhere. There's an angle coming down and it funnels right to the center of that hole. It's hard to see it on these because you can't see this. And then even in between the two holes, there's a cone built in around the die going around there. And then this cone may be a little bit taller and it comes down to a faded blend. That's level 3. But every die we do has its own solution. As for inserts, this would be a level 1 over here, and this is a level 3. We don't really do level 2s, and we try to do inserts as much as we can anyways, because it's simple to be the solution for that. But in something like this, there is a lot more thought and engineering that goes into it. So that's level 1, 2, and 3. So some of the testings for this, for dead space, is when you take your die out, you have material in there. Save that piece of material. Save whatever you get out of this thing. Save that. You can analyze it. You can send it to us. We can. Another thing that you can do is you can actually, before the end of the run, and this isn't something you want to do all the time, I get it, but if you threw in a different color of something or added color to it or whatever and extruded that through that, you would see exactly what was the one color and exactly what was the light color, and it would be a game changer to know what dead space you're having. Again, if you can eliminate your dead space, you are going to most definitely, without a doubt, improve your production. That's it for Die Talks. I'll talk to you guys later.